On YouTube and on the web in general, you can find many arguments for the assertion that free will is an illusion. Most of these arguments are based on causal determinism, the idea that everything that happens, everything we do, is really caused by circumstances beyond our control. I'm going to give a different argument today. I'm going to argue not that free will is an illusion, but that causal determinism is an illusion. And that's me. First, here's an outline of what I'm going to talk about. In this video, I'll set the stage. I think it's important for me to define the terms I'll be using, because all too often we have arguments over words simply because we're using the same words in different senses. So I'm going to explain what I mean by an illusion. I'm going to explain what I mean by causal determinism. In the second video, I'll give some suspicious evidence from physics, including the nature of time, some other aspects of classical and quantum physics. And in the third video, I will present an alternative that I believe is both reasonable and beautiful. First, what's an illusion? Something that appears to be what it isn't. I'm sorry, that sentence somehow seems ungrammatical, but it gets the point across. An example, the sun moving around the earth. Now, the sun moves through the sky, just like clouds or birds. We throw a ball in the air and it moves through an arc. Why should the sun be any different? Furthermore, it's obvious that we're standing still. Everybody knows that. We're not moving. On the other hand, as far as astronomers were concerned, not everyday people, but astronomers, the Copernicus system gave a much simpler explanation of what astronomers saw. At first, even some astronomers treated Copernicus' theory as a convenient mathematical fiction. So, let me bring out some points here. This idea that the sun moves through the sky, just like clouds or birds, is based on a compelling but faulty or incomplete analogy. This idea that it's obvious we're standing still comes from common sense. And common sense leads to unexamined assumptions. The Copernicus calculations give a simpler explanation that shows that beautiful mathematics reveals deeper truth. What this tells you is that you should take the mathematics seriously. And if you hear someone calling a mathematical theory a convenient mathematical fiction, you should beware. I say this because even in modern physics, some theories are described this way. But this example shows that maybe we should be careful about calling mathematical theories fiction. And if they work, it may be showing us something very deep and profound. Here's another example of an illusion, friction. Aristotle and the Greeks thought that things naturally stop moving once you stop pushing them. Heavier things naturally fall faster than lighter ones. Now, of course, this is what we see happen in everyday experience. If you push an object across the table, you stop pushing, it stops moving. If you drop a rock and a feather, the rock falls faster. It's obvious. And of course, there are exceptions, but these can be explained. All right, so this obviously happens from everyday experience. Now, people like Da Vinci and Galileo studied the phenomenon and related it to things like roughness of the surface and adhesion, and developed equations to explain it. And these investigators came to the conclusion that friction is not a primary effect, but a secondary effect. Now, I want to point out that even though I'm calling friction an illusion, we couldn't live without friction. You couldn't walk down the street. Your clothes wouldn't hold together. our lives would just fall apart without friction. So calling it an illusion doesn't mean that it's not important. It's certainly a critical phenomenon in our lives. So let me summarize some points from this example. Again, we have a faulty or incomplete analogy leading to an unwarranted conclusion. Again, we have common sense that leads to unexamined assumptions. And also want to point out that the fact that we now understand friction as a secondary effect makes us much better able to utilize it in technological advances. When people developed cars or other instruments of locomotion, understanding of friction was key. And as I said, just because friction is in some sense is an illusion doesn't mean it's unimportant. Okay, so friction is not as fundamental or key in the natural world as it appears to be. So let me define my other main term, causal determinism. We can explain this in terms of the so-called law of cause and effect. Anything that happens, the so-called effects, can be explained as a consequence of previous events, the so-called causes. Right? But the idea of cause is not so clear as it seems from our common sense notions. So what is a cause? Well, one philosophical definition comes from David Hume. The idea that X causes Y means that X's are constantly conjoined with Y's. They always occur together. Y follows X and not vice versa. So the cause precedes the effect. And there's a necessary connection between X's and Y's such that whenever X occurs, a Y must follow. Okay, so this seems reasonable. And this is not the only philosophical definition of cause, but they all have their own problems. Okay, so let's see how this definition works in practice. Just to remind you, the three components of the definition, that if X causes Y, X and Y are constantly conjoined, Y follows X, and there's a necessary connection between X and Y. Right now, I always put socks on before I put on my shoes. Does putting on socks cause me to put on my shoes? Well, they're constantly conjoined. I always put my shoes on after I put on my socks. So putting on shoes follows putting on socks. And it seems that there's a necessary connection between the two. Okay. However, we would not say that putting socks on causes you to put on your shoes. Now, another example, I always drink from a water fountain after I push the button. So does pushing the button on the water fountain cause me to drink water? Okay. According to, we see these three aspects of the definition. They all seem to be satisfied. But there seems to be something wrong with this application. It wouldn't say that pushing the button on the water fountain causes me to drink water. In fact, I want to drink water, so I push the button and drink water. The two happen together, but one doesn't cause the other. So correlation is not causation. What appears to be a cause may be a correlate. The two things that always happen together may both be due to something else. Okay, there may be problems with these philosophical definitions. Let's go to physics for the answer. What is a cause according to physics? In physics, a cause can be identified with initial conditions. An effect can be predicted by means of these conditions plus an equation in which time is the independent variable. Okay? For example, Newton's laws of motion. You have a coconut and it loses its connection with the tree and falls from the tree and hits the man on the head. Now, the initial condition is that the coconut is no longer attached to the tree. You have Newton's law of gravitation. You use F equals ma. The acceleration of gravity is constant. And you can predict and explain the trajectory of the coconut as it falls from the tree and hits the man on the head. So we'd say the coconut falling on the tree caused the man to be bumped on the head. Problem. According to physics, the cause could just as well be in the future as in the past. Okay? You could have the coconut striking the man's head, take that as your initial condition, run the equations of motion backwards, and predict its falling from the tree. As far as the physics is concerned, there's no preference the one over the other. The physics doesn't say you have to take time forward. The physics says that what happens in the past can predict the future, and what happens in the future can predict the past. Okay. Now, I think it's appropriate to ask the question, is causal determinism logically necessary? And as far as I can see, the question is almost never addressed. In most scientific and philosophical arguments, causal determinism is simply assumed. There's St. Augustine's famous argument for God, that everything we see has cause, and causes have causes, and there must be a first cause, who is God. On the other side of the philosophical divide, you have Sam Harris and others. Here's a quote from Sam Harris. Human thought and behavior are determined, that's my underlining, by prior states of the universe and its laws. And any contribution of indeterminism are completely irrelevant to the question of free will. So in other words, things are basically caused. We are what we are because of things that happened before we were born or beyond our control. And here we have a fundamental deterministic picture, but there's no proof. It's simply assumed. Unexamined assumptions are dangerous. Now we can ask the other side of the question, how could causal determinism not be true? Well, let me give you an example. When I was a little boy, my grandfather had a summer home on Cape Cod. It's a place I love to go, and I used to watch the fishing boats come in. He lived on Pleasant Bay, and the fishing boats would come in from the ocean. So here's a fishing boat. And here's me on the beach. So here's the beach. And here's the fishing boats. And of course, as the fishing boats comes in, it leaves a wake. So the waves come off of the fishing boat like this. And it used to fascinate me that when the waves hit the beach, it looked like the wave was running down the beach. It looked like the point where the wave broke was moving down the beach. Now, of course, the wave breaking here comes from here. The wave breaking here comes from here. They're not the same thing. But it appears to be one thing moving down the beach. It appears that what happens here causes what happens here. Now, I think maybe you can see my analogy here. Suppose this beach represents the universe. And suppose this direction, in some sense, represents time. And the fact that we see things that happen in time that have antecedents, that in some sense explain them, does not mean that these antecedents caused what happens in the future. It's quite possible that there's a cause somewhere else, not in what we observe or see, that makes both of these things happen. Okay? Now you might say, why even presume that there is a cause somewhere else? We see what we see. Why do we need something else to explain it? Well, I'll go back to the analogy with Copernicus. Why assume that the sun is not moving and the earth is moving around the sun? It's because when you get more into the details and look more carefully at what's going on, the picture that the sun moves around the earth is inconsistent and causes difficulties. And in my next video, I'm going to argue from physics that this is exactly the case we're in. If we look more closely at reality, this idea that things in the past cause things in the future is evidently an incomplete and inconsistent picture, and we need to start looking somewhere else for causes. Because of my own faith and the faith of many others, I find this to be an important question. What does the Bible say about causal determinism? Now, it's interesting that the Bible describes future events as prior to past events. In several places, Jesus Christ is described as the Lamb slain before the foundation of the world. Before the beginning of the world, Jesus Christ is already, in some sense, the Lamb who was slain. If you look at one of the well-known prophecies of Jesus' coming, he was wounded for our transgressions, he was bruised for our iniquities, the chastisement of our peace was upon him, and with his stripes we are healed. Now here it's talking about a future event in the past tense, as if it had already happened. So which causes which? Which determines which? It appears that the death of Jesus Christ for our sins is causally prior to the beginning of the world. So here's an idea that causal determinism may be turned on its head. The Bible suggests a non-deterministic picture of reality. Okay, so that's it for this video. In the next video, I'm going to give some reasons from physics that suggest what appears to be cause and effect may in fact simply be correlation. Remember the example of the waves on the beach that I gave. Okay, thanks for listening.